Hello and welcome to today's episode. Today's subject is disaster recovery concept, plan for disaster recovery, and strategy to improve application reliability. I have selected today's topic from some of my friends and followers' request. This is a very important topic, especially if you are responsible for building highly available application architecture or if you are planning to take any AWS certification. You have to know this topic in and out. I have tried to explain all the concepts with animations and diagram such that you can have a deep understanding on this topic at the end of this episode. Disaster or accident can appear anytime and it can come with its own beauty. If we as an organization is not prepared or planned well, then it can create a massive impact wave which can not only impact company's revenue but reputations and customer faith also. That is why it's very critical for every organization to plan for its business continuity to handle any such unforeseen events. Without any further delay, let's get started. First, we'll discuss some basic terminologies. I know availability and reliability. Although the concept is very different, but sometimes it's create confusion in our mind and we used to mix up with this term. That is why I would like to explain availability and reliability in more details such that when we will go more and more into the subject, this confusion will not create any problem or it will not create any block to understand the further concepts. First, let's see what is availability. As per definition, availability is percentage of time that a workload is available for use. Now let's see with the help of a diagram. Let's say you have an application and you have application users. So whenever user is trying to access your application, if your application is available or if your application will be able to serve user request, then it's availability. Now from this definition, let's say if your application is not available for 5 minutes in a year, then it will be considered the availability of your application is 99.999%. The next concept is reliability. By definition, reliability says ability of a system or application to perform its intended function correctly and consistently when it's expected to. Let's see this definition with the help of a diagram. In our previous example, you have this web application and you have your application user. Now let's assume your web application will take some input and give the summation of those input. Let's say your user is trying to add two numbers, 2 and 2. At first attempt, what he got 2 plus 2 equal to 4, which is correct. But at second attempt, he got 2 plus 2 equal to 5. That means your application is not behaving how it should, and this is the issue with reliability. Now if this concept is still not clear, I would like to take another one example from our day-to-day life. Let's say you are traveling very frequently to a particular destination. You are using some airlines carrier. Let's say you reach airport, that flight or the plane is available for takeoff. That means that flight is available. But you are supposed to reach, let's say 10 a.m. or 11 a.m. But every time whenever you take this flight, it takes certain route or it may create some other magic such that it will always delay for 2 hours or more than 2 hours. That is the issue with reliability. I hope now the availability and reliability concept is clear for you. Now let's see why availability and reliability is both important for you. Without availability, your application will not be accessible. That means your user will not be able to access your application. That is why availability will make sure your application is accessible round the clock. On the other hand, reliability will make sure your users or your application users will have a consistent user experience. That is why you should focus both on availability and reliability when you are building any application architecture. Now we'll discuss two most important concepts in disaster recovery. Let's say this is a database application you are maintaining as part of your application architecture, and this is a timeline. Let's assume your application or architecture has been built where you are taking backups every 6 hours. You took the backup, let's say at 12 am, and your next backup has been scheduled, let's say at 6 am. In between, disaster strike around 4 am. That means between 12 to 4 am, there were no backup. Whatever the data, whatever the information your application processed, there is no backup during this time frame. After the disaster, your engineering team worked on your infrastructure, bring the application back, and let's say around 8 am, your application again brings back to normal. It is working properly. Now, between 12 am to 4 am, you do not have any backup of the information your application processed. This time is considered as recovery point objective. And between 4 am to 8 am, this is the time you took to rebuild your application or to bring back your application. That is why this duration is called recovery time objective. Now, let's understand with definition. Recovery point objective is maximum acceptable amount of loss of data between the last recovery point and the interruption of service. Whereas RTO or recovery time objective is the maximum acceptable delay between the interruption of service and restoration of service. RPO is defined how much data you can afford to lose, whereas RTO will define how quickly you must recover from any disaster. Hope this concept now clear to you. Now let's discuss scope of impact for disaster event. Again, every application is unique and every application can have their own RTO or their own RPO. Based on your application's criticality, you have to decide the disaster recovery strategy. Today, I'll discuss mainly two. The first one is multi-AZ strategy. As you know, every AWS region comes with multiple availability zones. Within every availability zone, there could be 2 or 3 isolated data centers. Now, you build your application or you create a VPC spanning across multiple availability zone. Inside every availability zone, you have created one subnet and you have placed your application or EC2 instance inside each subnet. Now you can create one application load balancer which can distribute traffic to all your application instance. Now let's assume disaster strike on any one availability zone. Then also your application will be available and will be able to serve traffic from other two availability zone. That is why this is called multi-AZ strategy. Now what is the significance? With this strategy, you are reducing the risk of single event impacting more than one availability zone. In case more than one availability zone goes out simultaneously, then also your application will be able to serve users traffic if you have planned accordingly or if you have used multiple availability zone while considering your application architecture. On top of that, if you have auto scaling group, your application can scale seamlessly based on application load. Now what is the scope? Event such as power outage or maybe flooding or other local disaster that can impact one or more availability zone. That means you are protecting your application's availability from local impact or local disaster like power outages or flooding of an entire zone, right? Now we'll discuss multi-region strategy. In this multi-region strategy, what you are doing, you have created your application inside one region. Let's say you have created region 1 as US East 1, where you have span your application across multiple availability zone to cope up with local disaster. On the same time, you have replicated your application architecture in a secondary region, let's say on US East 2, and you are distributing the traffic with the help of AWS Route 53. You can use any routing strategy, right? In case of entire region went down, still your application will be able to serve traffic from the secondary region. Now you can understand, if you are spanning your application over multiple regions, you are taking into consideration impact of bigger scale, not local impact. It could be a catastrophe. Now what is the significance? You are reducing the risk of larger event impacting an entire AWS region. Now let's discuss disaster recovery techniques. AWS suggests 4 different options based on criticality of your application and your financial goal. We will discuss all these techniques in great details. The first option is backup and recovery. What you have done, you have created your application in one region. Let's say you have created your application in region 1, which is US East 1, and this is your primary region. Your architecture consists EBS backed EC2 instances and RTS MySQL instance. You are taking regular backups or snapshot and you are storing those snapshots to a secondary region, let's say US East 1, in a S3 bucket. When disaster strike, you are building your application from the latest snapshot that is stored in the secondary region. Now, here you can understand, you are restoring backups after the event and you are provisioning all AWS resources after the event. Although this is the lowest in cost, but it would be for low priority use case. Your application demands 24/7 availability or close to 99.999% of availability. Obviously, this technique is not for you. But if your application is not mission critical and your application can sustain a RTO and RPO of hours, in that case, this would be the better architecture for you in terms of cost. RPO would be in hours, maybe 2 hours, 3 hours, or maybe more. And on the same time, RTO will be in hours. As you know, you need some time to restore those backups and to bring back your application in full scale. That is why when you have RPO and RTO in hours, you should consider for backup and recovery technique. With this, you will save a large amount of infrastructure cost every month. Now let's discuss option 2, which is pilot light. Let's say you have built your application in region 1, which is US East 1 in our example, where you have one application load balancer. The application load balancer is distributing the traffic to auto-scaled EC2 instances, and you also have one RDS MySQL database. This is the architecture in your primary region. On the same time, you have provision secondary region or DR region in US East 1 in our example. There you kept a synchronous backup of your application data, and you have created an auto-scaling group with, let's say, 0 capacity. That means you do not have an EC2 instance provision in your DR region, but when required, your auto-scaling group can scale up quickly. When disaster strike in your primary region or US East 1, you can quickly promote your database replica to a master database, and then you can launch EC2 instances, or you can configure your auto-scaling group to launch EC2 instances quickly based on the application load, and you can create an application load balancer in your disaster recovery region or DR region to distribute the traffic. That means when disaster strike, you can quickly replicate your application to a disaster recovery region, and in this architecture, you are minimizing the impact of less data loss. Here the significance is synchronous copy of your data is always available in the DR region. Services are either idle or they are switched off. But you can provision AWS resources very quickly. Maybe you have provisioned very less amount of AWS resources, which is very critical. In this technique, you provision some AWS resources and you can scale after the event. Now you can understand this is relatively higher cost than the option 1 or backup and restore strategy, because here you are provisioning some AWS resources or you are duplicating some AWS resources across regions. You can understand in this option your RPO will be in minutes, or when your application demands RPO or recovery point objective in minutes and you cannot afford to lose data more than 10 minutes. Maybe your RPO is 5 minutes or maybe less. In that case, you should consider this type of architecture. Whereas the RTO will be tens of minutes or maybe 20 minutes. Now, you can understand based on your application criticality, if your application demands a RPO of minutes, maybe less than 5 minutes, whereas RTO of tens of minutes, maybe 30 minutes, 40 minutes, then this is the best architecture for you. You should consider for disaster recovery. This will give you a better cost benefit as well as it will hold all the RPO and RTO requirements. Now next option is warm standby. Now let's consider you have created your application architecture in region 1, which is US East 1 in our example, and inside that you have, let's say, some critical application, data processing or natural language processing or maybe machine learning application which is very critical for your application to run. Let's consider your application architecture consists of an external load balancer or external application load balancer which is distributing traffic to a group of auto-scaled web servers, and you have another one internal application load balancer which is distributing the traffic to a group of auto-scaled application server, maybe that resides in private subnet, and you have a MySQL database in your primary region. Now in region 2, what you have created a synchronous backup or a standby of your database instance, your critical application, the machine learning application that you are running always, and you have a auto scaling group, one web server and one application server running. When disaster strike, you can quickly promote the backup or the standby database to a master database, and you can quickly scale up your application servers, your web servers, and you can add external and internal load balancer. That means after disaster strike, you are scaling up your application, whereas a critical core of your application is always running. This is the important point. A critical core of your application is always running in disaster recovery region, and you are scaling up when disaster strike. So the significance is you always have a synchronous copy of your data in disaster recovery region. Only business critical or scaled down version of your application is always running in DR region. You are scaling AWS resources after the event, and you can understand since a scaled down version of your application is always running in DR region, this approach will be relatively higher in cost than Pilot Lite. And now in terms of RPO and RTO, it would be in minutes. If your application is critical and you cannot lose data more than 5 minutes, or maybe you have to bring back your application in less than 10 minutes, in this case or in that kind of use case, warm standby is the best fit for you. Now, the fourth option or the last option is multi-region or multi-site. In this architecture, your application span across multiple AWS region. You can see in this diagram or in this example, your entire application is replicated to another one secondary region. Let's say your primary region is US East 1 and your secondary region is US West 1. In this case, this is not a backup region. You are using an active configuration. That means a complete scaled or complete version of your application has been replicated to another one region, and you have one Route 53 routing technique which is distributing traffic between these two regions based on your requirement. When disaster strike in your primary region, your application will be able to serve traffic from secondary region. Since you have a full scale application running in a secondary region, you do not have to worry about any data loss here. Since your application is always running in a secondary region, you can have near real-time RTO and RPO. Now, in terms of significance, active configuration which is running across multiple AWS regions, you will have zero downtime and near zero data loss. This is applicable for mission critical application when your application demands 24/7 availability. Obviously, this will be highest in cost, and in terms of RPO and RTO, you can understand there will be potentially zero RPO or potentially zero RTO. Now, if you have scaled your application properly or if you have configured your auto scaling group properly, there will be a zero potential downtime or zero impact on application performance. So this technique again is applicable if you have a mission critical application where you cannot afford a single second of data loss or single second of unavailability. Now let's summarize all those disaster recovery techniques, or let's compare all those disaster recovery techniques. I have taken this diagram directly from AWS documentation. Backup restore, pilot light and warm standby. In this technique, you have an active passive configuration. That means your application is available in one active region and you are either backing up or either you are storing the application snapshot in case of backup and restore, or you are keeping only the data copy or synchronous copy of your data in the pilot region approach, and in warm standby, a critical core of your application is always running. Whereas in multi-site is a active configuration where you have more than one region or your application replicated across region serving traffic simultaneously. Coming back to RPO and RTO, for backup and restore, RPO and RTO will be in hours. For pilot light, your RPO will be in minutes and RTO will be in terms of tens of minutes. Under warm standby, your both RPO and RTO will be in terms of minutes, whereas for active multi-site configuration, your RPO and RTO will be near real time or potential zero. And at the end, you can understand more you will go from left to right, your cost will also increase. Backup and restore will be lowest in cost, whereas active multi-site will be highest in cost. Active multi-site is for mission critical application. Backup and restore for such application where it does not demand, or if your application does not require or your application can sustain an hours of RTO or hours of outages. This was all about today's episode. At the end, I would like to thank you for your valuable time. Please don't forget to subscribe our channel to get unique and exciting opportunities on a regular basis. If you like my effort, please like this video and share with your friends. And last but not least, please don't forget to drop your feedback as comment to this video. Happy learning, please stay safe and take care.